This is lesson 9.2, redox equations. So half reactions are separate equations for oxidation and reduction. And we use half reactions for balancing redox equations. So to balance a redox equation, it's not as simple as it used to be, where you could just add up the atoms on the left and add up the atoms on the right, because now you have electrons coming into play. So the first step to balancing a redox equation is to assign oxidation numbers to determine oxidation and reduction. The second step, you're going to write your half reactions for oxidation and reduction. Next, you're going to balance your atoms other than hydrogen and oxygen. Then to balance each half equation for oxygen, you're going to add water to one side. But then you'll probably have more hydrogens on one side than the other, so you're going to balance each half reaction for hydrogen by adding H+ as needed. Step 6 is you're going to balance each half reaction for charge by adding electrons. And then you're going to equalize the number of electrons in the two half reactions by multiplying each half reaction by some number to find the lowest common denominator. And the last step is you're going to add the two half reactions together and cancel any similarities. So please make sure that you've copied all of these steps. They're all very, very important. So here's an example for balancing a redox equation. Here you have nitrate plus copper going to nitrogen monoxide plus copper ions. And you can tell it's redox because the copper is changing charge, which means that something else must also be changing charge, because remember, you can't have oxidation without reduction. So the first step is that you have to go through and assign oxidation numbers to determine what is being oxidized and what is being reduced. So we know O is -2 for a -6 total, which means N must be +5. Copper is 0. O is -2, so N is +2, and copper is +2. So now we're going to split our equation apart. So nitrate is going to nitrogen monoxide because the N is what is changing. And we know N is going from +5 to +2, so it must be gaining electrons, so it's reduced. And copper is losing electrons because it's going from 0 to +2, so it's being oxidized. So that was step 2, writing our half equations. Now we need to balance our equations for atoms. And since we only had one N here and one N here, we were good. And one copper, we were good. So the next step is to balance our equations for oxygen by adding water. So here we have 3 O's, and we only have 1 O here. So we need 2 more O's on the right. So we're going to add 2 waters. Well, now that gives us 4 hydrogens. So we need to go back and add 4 hydrogens to the left by adding H+. The copper was okay because we didn't have any O's or any H's, so we could leave that one alone. The next step is to balance the charge by adding electrons. So to do this, we add up everything on the left, so 4 positives and a negative gives us a +3, and there's no charge here. So we know that we need to add 3 electrons to the left-hand side. And here we have a charge of 0 and a charge of +2. So we know we need to add 2 electrons to the right-hand side. The next step is to make the electrons equal. So to do this, the lowest common denominator is 6. So we're going to multiply everything in this equation by 2 and everything in this equation by 3. And then we'll rewrite. So we get 6 electrons plus 8 hydrogen ions plus 2 nitrates goes to 2 nitrogen monoxide plus 4 water. And in the second equation, we will have 3 copper goes to 3 copper ions plus 6 electrons. Now we can see that we have 6 electrons on both sides. And so we can cancel out those 6 electrons and rewrite our balanced redox equation. So 8 hydrogen ions plus 2 nitrate ions plus 3 copper goes to 2 nitrogen monoxide plus 4 water plus 3 copper ions. And that gives us a balanced redox equation. And we can check this redox equation by adding up. So we have 8 hydrogens, 2 nitrogens, 6 O's, 4 O's plus 2 O's is 6 O's, and 3 copper. So we know that we are correct. Now we have a few definitions that are important for redox. The first is the definition of an oxidizing agent. The oxidizing agent is the reactant that is being reduced. It is the one that is actually doing the oxidizing. So it's the one that's being reduced. And vice versa, we have reducing agent. The reducing agent is the reactant that is being oxidized. So it's not being reduced, it's being oxidized because it's causing the reduction.